All right, let's try using some of our tools in an actual proof here. So typically your proofs, they may have a picture, they may not, and they're going to give you some given information, and they're going to tell you something that you need to prove. So here we've got our picture, we've got 4 different points, P, Q, R, S, and they're all on the same segment. Since we do have a picture, it might be a very good idea for us to kind of label the picture as we go through to help us understand and make some sense of what we're trying to prove. So here we're given that PQ is equal to RS. So we know that PQ here is equal to RS here. All right, well, since I know that, I'm going to go ahead and give myself some congruent lines just so I can have a visual representing that. PQ equals RS. Now they want me to prove that PR is equal to QS. Okay, so let's see. They're asking me to prove that PR is from here to here. PR is equal to QS. Alright, well, to start things off, you always give yourself a statement reason chart if we're doing a 2-column. And then we always start with what's given. So our first step's always easy. We say PQ is equal to RS, and the reason is given. That's always your first step. Here we have given PQ is equal to RS, and we just rewrite that down here. Okay. For my second step here, I did notice that they wanted us to say that PR was equal to Q. Sorry, they want us to prove PR was equal to QS. Now I noticed that they had this little common ground here, which is QR. Now since QR is in common between them, I might try to make it so QR is involved in both of them. So what if I added QR to each piece I had? So let's say PQ plus QR, that's going to be equal to RS plus QR. Now we can do that. We just added QR to both sides. So that would just be our addition property, like we did in our algebra proofs. That would be addition. I'll just put a P for property, addition property. Okay, next, I'm noticing that we've got PQ plus QR. Now PQ plus QR is going to give me, if I added those together, my PR, which is what I'm wanting in my proof, is PR. PQ plus QR gives me PR. So keeping in mind what I want to prove, that's going to help me get a direction for this. So why don't I go with that? Let's say PQ plus QR is going to equal PR. Likewise, I can say that RS plus QR is going to equal, what do you think? RS plus QR, that's going to equal this big segment QS. And that's exactly what I want to prove. So looking at what I want to prove is a clue to help guide me in my proof. So QR, and that's going to equal to QS. And since we added little pieces to make a big piece, our reason is segment addition. Okay, finally, I have this whole thing here. I have PR, I have QS, and looking back at step 2, I had PQ plus QR. Well, I know PQ plus QR is PR, so I could say that PR, oops, sorry, I can say that, let me erase that. I can say that PR, and now notice I'm substituting PR here. I have PQ plus QR, PQ plus QR, and I'm substituting PR in right here. I'm substituting that in, I'm substituting the PR in for PQ plus QR because I know that's equal. So I know I'm using substitution. Now here I can also substitute in my QS for RS plus QR because I have RS plus QR. So I can say that PR equals QS, and since I substituted those in, I'm going to say substitution, and that's exactly what we wanted to prove. PR is equal to QS. We did it. So we're done. Okay, let's try another one. Here, we are given that JK is congruent to KL, so you know JK is congruent to KL. I'm going to go ahead and label here my picture to help me out. JK is congruent to KL. We also know that KL is congruent to JH. Okay, well KL is congruent to JH, so I could put another congruent mark here. Also, I know that JH is congruent to HG, so JH is congruent to HG. Well, I know that that's one congruent line, so I can put another congruent line here. They want us to prove that JK is congruent to HG. Well, looking at my picture here, I've got JK is congruent to HG, and you might be thinking, well, they're all congruent to each other, so isn't that obvious? Well, in proofs, things can't be just stated as obvious. You have to prove to the biggest skeptic that they were true. Russell and Whitehead, once two famous mathematicians, they took 300 pages to prove that 1 plus 1 equals 2. So just because something seems obvious doesn't mean we don't have to make a proof here. So just like always, let's start with our statement and our reason column. My first step, going to draw out my column. I do squiggly lines because they bring joy to my heart. And we're going to start with what is given. So we can list here, we can list JK is congruent to KL. We can say that KL is congruent to JH. And we can say that JH is congruent to HG. And this is all given. So our first step is always very simple. Take what's given, just like before, put it in our statement, our reason, and then we're moving on. Okay. Now I'm thinking back here. I can't just transfer this first one all the way across to the fourth, but I do think back to the transitive property. That one we can transfer through one. So I'm going to go ahead and take this JK congruent to KL. KL is congruent to JH. Oh, that is not a very beautiful JH, but nonetheless JH. So let me go ahead and say that JK is congruent to, you're going to go through KL to JH. So I can say JK is congruent to JH, and that is going to be my transitive property. Okay, now I know that JK is congruent to JH. I also know JH is congruent to HG, so I can say that JK is congruent to HG, and that's also going to be my transitive property. And that's actually what we're trying to prove, isn't it? JK is congruent to HG. JK is congruent to HG, so I knew where I wanted to go, and I just transited myself through all the way to HG, and this proof is done. Alright, by now some of you guys might be kind of interested in these proofs, kind of like a puzzle, trying to figure out how to put the pieces together to get where you want to go. And some of you might be saying, oh my goodness, how am I ever going to understand these? Hey, proofs use your brain power. So if it's not making sense right away, that's okay. You have to persevere. You have to try to piece it together, figure it out. Make sure you're using appropriate steps. And as you practice them, as you start getting the hang of it, you'll get better and better, and you'll see what kind of tricks there are to get to where you want to go. Hey, you're not going to necessarily prove it your first try. It might take you 2, 3, 4 tries. Some people have worked their entire lives trying to prove a single theorem or a single idea. So just because you don't get it right away doesn't mean you're not capable of doing it. That's what it's supposed to do. It's supposed to work your brain, make you think, make you problem solve, and figure it out. Okay, let's go ahead and do one more example before I set you off on your own to try some of these out. Alright, so just like always, I'm going to look at what my given information is, and I'm going to see if I can draw anything on my picture to help me out. So I have given that HI is congruent to TU. Alright, well, let me go to my picture, and I know HI is congruent to TU, so I'll give myself some congruent marks. I also know that HJ is congruent to TV. Alright, so I know that this big segment, HJ, all the way from here to here, is congruent to TV. So I'm going to go ahead and give myself some congruent marks. Since I can't put 1, I already have 1, I'm going to go ahead and put 2 marks there. I apologize for my U and my V. This is a U and a V. Don't get confused by those. So now I've got my picture labeling everything that's given. They want me to prove that IJ, they want me to prove that this segment here, IJ, is congruent to UV. Okay, let's just think about this before we get started. Well, if I know that these small pieces are the same, these two small pieces, and I know that the whole big piece is the same, you might say, well, obviously that these pieces, this other small piece has to be the same because it has to add to the same total, and you'd be right. So now the trick is, how can we formally write that? How can we write that step by step to explain that? So first step, like always, let's give ourselves a statement and a reason chart. Okay, and what's our first step? Always we use what's given. So we have HI is congruent to TU. We also have that HJ is congruent to TV, and that U is just terrible. I apologize. Let me change that to more of a less terrible but still terrible U, but at least you can distinguish it. So here we have our given information, and that's going to be our reason, is given. Okay, next, moving forward, let me look at what I want to prove. I want to prove IJ. I want to prove these small pieces are equal to each other. Well, I see that I have a big piece and the little piece, so I might start thinking of segment addition because I have two small pieces that add to a whole. So let's go ahead and go with that idea and see if that gets us somewhere. So I can say that the big piece, this HJ, I can say that HJ is going to equal to the two small pieces added. That's HI plus IJ. And then I can also take the same thing for my other one. I know that this big piece TV is equal to the small pieces added together. So I'll say TV is equal to TU plus UV. And I'm just adding the small pieces to the big piece, so that's going to be segment addition. And you know what, I think I'm going to zoom myself out here because I'm running out of space, so give me a second. I'm going to extend my chart here. Alright, third, what can we do now? Well, let's look at what we've got. We've got HJ is equal to HI plus IJ. Okay, good. We've got TV is equal to TU plus UV. Alright, it seems like we've got everything in order. Now, oh, I also know that HJ is equal to TV. Well, I've got HJ here, and I've got TV here, so maybe I can set these two things equal to each other. I can set the small pieces equal to each other. Let's see what that gets me. So we can say that HI plus IJ is going to equal TU plus UV. Hey, go ahead and write these steps down maybe as I'm saying it, because I feel like it's getting a little hard for you to see my writing. It's not the easiest to write with my finger on here, and I don't have the best handwriting to start. So if you want to write this down, this is HI plus IJ equals TV plus UV. And because I took these values and I switched them with each other, I knew that these equaled each other from up here. That's just going to be substitution. Substitution. Okay, let's see here. Well, I also know that, well, let's take a look here. I'm trying to prove IJ equals UV. Well, I've got IJ here, I've got UV here, but I've also got this HI and this TV attached to it. Well, I know that HI is equal to TV, right? So let's go ahead and even put those together. So instead of HI, let's replace HI with this TV. So I'll say TV plus IJ is equal to TV plus UV. And I know that's going to be substitution again because I'm replacing that value. Substitution. And let me give myself even some more. Whoa! a little bit more space here, and now I know that if I minus TV from both sides, since I have it on both sides, that'll give me ij is equal to uv, and that's what I wanted to prove, was that those were congruent. Ij is equal to uv, and that's just going to be subtraction. And oh, I suppose I should give myself just one more step possibly. So let me go ahead and say my sixth step, I don't want to prove the distance is equal, I want to prove they're congruent. So I can say ij is congruent to uv, and that's going to be the definition. This is my sixth step, definition of congruent segments. Okay, so we've got to where we want to prove. Again, it was kind of a process here. We had some trial and error. We had to figure some things out, but we eventually got to where we wanted to go. Using what we want to prove to kind of guide us is a big help. And remember, work through it. You might need to start over. You might need to think through, label it first, and then figure it out. It doesn't always come your first try. So as you practice, I encourage you, stay positive, persevere. You're going to get better at it, I promise. All right, signing off.